Okay. So, um, STM32 MP2 series. It's a new series of microprocessor for ST. It's a follow-on to the MP15 series that we first launched a few years ago. So you can see here the portfolio that we have today. STM32 MP15 was the first ST MPU that we launched. Dual Cortex A7 at 800 megahertz. A single Cortex M4 for the real-time processing capabilities. 32-bit DDR3, LPDDR3, and LPDDR2. A GPU and single gigabit Ethernet. We followed that up a couple of years ago with the STM32 MP13. Here, this was targeting the lower cost part of our portfolio. So single Cortex A7 only, 16-bit DDR. But we did introduce dual gigabit Ethernet and some security improvements on those products. The MP1 series, both 1.5 and 1.3s, are 32-bit microprocessors. We now move to the latest generation of our offering. So with the first being the MP25, the STM32 MP25. This is a 64-bit Linux processing device. Dual Cortex A35 at 1.5 gigahertz. Single Cortex M33 at 400 megahertz. 32-bit DDR and DDR4 this time. So we've now moved to support DDR4. There is also compatibility to support DDR3L. Primarily, we target DDR4 and LPDDR4. We have 3D GPU in there, and we also have an NPU, neural co-processor support. So we can support hardware acceleration for machine learning. There's also a H.264 encode decode block. We've increased the Ethernet capabilities on the device. So we now have up to 3 gigabit Ethernet ports, all supporting TSN. And there's an embedded switch in there to offload the packet switching processing from the core into the switch. There's also PCIe version 2.1 and USB 3 supported. So that's the first generation, the MP2. We will very shortly be following it up with the MP23 family, slightly cost reduced version of this and feature reduced. So we'll have a dual Cortex A35 at 1.5 gigahertz, same as the MP25. Same Cortex M33 as well. Here we switch to 16-bit DDR. So again, DDR4, LPDDR4 and DDR3L. We still have the GPU and NPU. H.264 decode only in this case, and we step down to dual gigabit Ethernet and no switch. And then in the first half of next year, we will launch the MP21, the value line, if you like, MP2 product. So single Cortex A35, single Cortex M33, this time at 300 megahertz, 16-bit DDR again, and dual gigabit Ethernet. So why the MP2 microprocessor series? What does it offer? Well, as headlines, it offers a number of rich peripheral interfaces to support your applications, whatever that may be. A lot of embedded peripherals, standard embedded type peripherals, but also things like the GPU, the MPU, etc. Strong security. Step up in security versus the original MP1. We've improved security there. We moved to 64-bit architecture with the MP2, giving you advanced compute abilities. And we support embedded industrial applications with its robustness. And I'll just touch on that in a slide to come. So it is designed for, very complex applications, whether that be industrial, factory automation, smart homes, a smart city, that kind of thing. So whether it's gateways, PLCs, human machine interfaces, etc., we have the features and functionality to support these. When it comes to machine learning, because it's one of the key drivers of the MP2 with its NPU, we can support simple machine learning, such as anomaly detection, but then more advanced using camera, etc. So things like pose estimation, face recognition, etc. People detection, people recognition. On the security side, we can support secure boot, secure firmware updates. We have firmware and data encryption. And because we also support Trust Zone as part of the Cortex A and Cortex M architectures, we can support full context isolation. I mentioned about industrial robustness. The STM32 MP25 is designed for embedded in industrial applications and operating for 100% of its time for up to 10 years. That's whilst keeping within the junction temperature of -40 to plus 125 degrees. We offer 10-year longevity commitment, which is renewed every single year. This is exactly the same longevity commitment as we offer for MCUs. So January every year, we refresh the commitment. You can go to st.com and find the longevity page. And there you will see a list of all the parts that we cover. So designing the STM32 MP2 in, just like with the MCUs, should not be a concern for longevity, because it's going to be around for at least 10 years. Flexible resource allocation between cores. What do we mean by this? It means we can map the peripherals between the cores. So whether it's onto the Cortex A, the Cortex M, within or outside of Trust Zone, you can map the peripherals accordingly. And that's enabling us to keep the advanced security. In terms of edge AI and machine learning, we have the NPU accelerator, which operates at up to 1.35 TOPS. We have flexible ecosystem, which I'll talk about briefly towards the end of this slide set, which enables you to run AI and your machine learning algorithms on either the main CPU, on the GPU, or on the NPU, depending on the application and the complexity. So you have a choice, and you can compile it to suit how your application needs to run. We have the embedded multimedia capabilities for high-end HMI applications. So we have the 3D GPU supporting up to 1080p resolution, full HD video with the options for RGB, LVDS, and DSI outputs. And we have a MIPI CSI2 camera interface with an image signal processor embedded into the MP2. We also have within the ecosystem the ISP tuning tool, which enables you to configure it, and that is unique to ST. Okay, in terms of supporting the processing of your application, we have a number of features, a number of peripherals that can help accelerate your application and offload some of the need of the core into the hardware. So firstly, we have the gigabit Ethernet switch embedded into the MP25. So that enables us to support the packet switching at lower level within the switch without it having to make its way into the core and up through the stack to be switched. So we support that. Each of the Ethernet ports supports time-sensitive networking, TSN. And we have an acceleration module built in there to provide ultra-low latency pass-through operation. On the graphics side, We have the GPU, 3D GPU, running at up to 900 megahertz. It supports OpenGL ES 3.1, Vulkan 1.3, OpenCL, OpenVG, and OpenVX. And that means we can support up to 138 mega triangles per second. On the video side, we have a video encode and decode supporting H.264 up to full HD at 60 frames per second. We have JPEG encode decode at up to 500 megapixels a second. And to support this, there's 128K of embedded video RAM. On the display side, as I mentioned briefly earlier, we have three options. You can utilize 24-bit up to 24-bit RGB interface, MIPI DSi 4-lane, or LVDS, and we have dual LVDS. And then finally, on the camera side, we have the image signal processor. So up to 5 megapixels at 30 frames per second, black level calibration, contrast enhancements, and exposure control. And all of this can be tuned using the dedicated image signal processing tuning tool that we provide as part of the ecosystem. In terms of the security side, we have the Cortex A and Cortex M. Both have Trust Zone enabled. Both provide secure boot, secure firmware updates, and embedded hardware cryptography operations. We have secure provisioning within the ecosystem, and we have the ability to provide resource isolation, so isolating peripherals, isolating code, etc., within Trust Zone, etc. All this means we can support or be certified up to CSIP level 3 and ARM PSA level 1. Features that enable us to do that are memory and peripheral protections, so things like the memory protection unit, using Trust Zone to isolate the peripherals and the code. We have a secure cryptographic accelerator in there, which is side channel attack resilient. We have the ability for code isolation, and we have things like hardware unique key, which enable us to support device authentication and attestation. That's in terms of the hardware. Then we also have the STM32 Trust ecosystem, which is all part of the ecosystem, providing tools like OptE to give you a trusted execution environment, secure secret provisioning tool, and the Cube framework, enabling you to perform signing and key generation against your application. So there are three main families or subfamilies of the MP2 series. Here you can see the differences between the two, a short summary of the differences between the MP25, the MP23, and the MP21. As you can see, as you go left to right, it's basically feature reduction in order to optimize cost. So MP23, differences between the MP23 and MP25. Well, you have the same cores embedded there, same performance there. The GPU is reduced in capability. The MPU as well. We move to decode only on the video processing. We move to 16-bit DDR. We drop down to single lane LVDS for the display, and dual gigabit Ethernet with TSN on MP23. And we also remove USB 3 and PCIe. When we move to the MP21, there is no GPU, no neural processing unit, no video processing unit. Again, with 16-bit DDR. RGB 24-bit interface only for the display, but we maintain the same Ethernet capabilities, dual Ethernet with TSN and dual USB 2. Another way of looking at it is this slide. So you can see the summary of the differences between the MP25, 23, 21, but also the sub differences which within those families of the derivatives of the products, which I won't go into in detail here. The key takeaway from this slide is the pin-to-pin compatibility between the devices. Vertically, so between the MP25, say, if you're usually in the same package, they are pin compatible. The bottom half of this slide indicates to you how they are pin compatible between the sub-series of products. So, for example, if you take the TF-BGA 361 package here, then you have pin compatibility between the MP25 and MP23, allowing you to design one PCB to support multiple devices and therefore multiple SKUs of your application potentially. Obviously, you need to power the STM32 MP2, and in order to do that and to make things a bit easier in terms of the sequencing of the rails, supporting low power, etc., we provide a PMIC. So we have the ST PMIC. We have two variants of it. We have the PMIC 2.5, which supports the MP25 and MP23 fully, but not the MP21. And then we have the ST PMIC 2L, which supports the MP25, 23, and MP21. But just note here on the MP25, if you use the PMIC 2L, then the GPU isn't supported because it doesn't have the power supply for the GPU. So if you need GPU, you need to use the ST PMIC 2.5. Okay, so to touch on the ecosystem. So we've talked about the hardware. What about the ecosystem that goes with it? You obviously need software, you need development tools, etc. Like in the STM32, we have a fully featured ecosystem. We have the tools that you need to do your application. So in terms of embedded software, we get started. Our offering is Open ST Linux. There are others provided by third parties, other build frameworks, if you like, to support your development. So Open ST Linux is Yocto based, so that we provide the Yocto framework. If you prefer to use Buildroot or OpenWRT, we do have partners that support that and utilize our base software as part of that distribution. The STM32 MPU is fully covered by the STM32 Cube ecosystem as well. So that's the CubeMX, Cube IDE, etc. Cube Programmer. So the Cube Programmer can support you for programming the device, but also for doing the secure provisioning, OTP programming, programming external flash, etc. As part of the development of the ecosystem, we have development boards. Like with anything else, we have reference examples. I'll talk a little bit about these in the slides to come. We have the ability to do the hardware configuration. We have support available. We have the guys on the call today who are part of our support team, but also we have a lot of support which is easy to access in terms of the wiki, our developer network, etc. So we have a lot of information available to you in order to get started. And if you need partners to help you, we have partners as well that can support, whether that's hardware design, software design, etc. They can help. So what are the hardware tools to get you started in terms of reference designs, boards to get your prototypes going with? We have, starting from the left, we have the evaluation board, STM32 MP25F-EV1. This is a fully featured board. It has the MP257 on board it. As you can see, a number of connectors where the periphery is mapped out, including the 3 Ethernet ports, USB-C, etc. The board is the basic processing board. Not everybody wants a display. Some people do, but we decided to unbundle it. Previously we would put the display on the boards and sent it off. This obviously makes it more expensive to you to buy, and not everybody wants the display. So we've decoupled it from there, and the board is available to buy. The display is available to buy separately. So we have an LCD display panel that you can add. You have a camera module that you can add on. And we have a DSI to HDMI adapter board. On the EV1 board, we have a DSI output connection, and you can plug this board into it to support if you will need to use HDMI. Just recently launched is the Discovery Kit. So the STM32 MPU Discovery Kit. Giuseppe will go into a bit of detail about what's on this board as part of his presentation or introduction, but just to summarize, it has the single Ethernet port on there. It has the DSI to HDMI bridge already built in, so you have a HDMI connector on there. It has the USB 2 ports, it has USB Type-C port, and it has a Raspberry Pi compatible header on there, so you can connect hats that you might already have to the board. In terms of the embedded software, the rest of the workshop will go into much more detail about these. To just touch on this, we have 3 packages available for the embedded software. We have the starter package, which is essentially the binaries to put onto the reference boards, and so that you can quickly see the board running. We have the developer package, which is the first step to developing your applications for the STM32 MP2. And then if you need to create a full distribution, we have the distribution package, which lets you build everything from source as a complete package. Just to touch on the support for the ecosystem, we have a policy of 2-year support for each release, and we support 2 releases in parallel. So you can see here how the releases overlap. Basically, we do a full release, and then after 6 months we do a corrective support release. We do an update, and after 12 months we do the corrective support release. Then in parallel we will release a new version. We've just recently released the version 6.0.0 of the OpenST Linux. So on software development tools, as I said, the MP2 is fully supported by the STM32 Cube ecosystem. So that's CubeMX for to assist you with the device tree configuration and pin mapping, etc. Cube IDE for your code development, etc. And Cube Programmer for programming, doing the OTP programming, signing, and key generation. When it comes to reference hardware designs, with the EV1 and the DK boards, you can go to our website and you can download the schematics, Gerbers, etc. So you have a copy of the board design. You're free to copy and paste the sections of that you need for your design. But obviously that's 2 designs, considering 2 packages of the MP2. We have other packages available for the MP2. And so, although we don't have physical boards available for these other packages, we have done the reference design layouts so that you have a reference design for the high-speed DDR, etc. If you need it. So if you're using one of the other packages that isn't on the EV1 or DK1 board or DK board, you can use one of these reference designs for your design. On HMI, we're supported by all the key graphics framework providers. So whether Qt, Embedded Wizard, Crank, LVGL, etc., you can develop your graphic application using whichever framework you prefer. And then just on the to continue the embedded software, the OpenST Linux package offers the base configuration for the MP2. Um, but if you want to expand the capability of the ecosystem to support other functionality, maybe other devices from ST like NFC or GNSS or MEMS sensors, etc., we have add-on packages, so-called X Linux packages, to add that functionality into the ecosystem so that you can be, you have the full support. And these packages have the drivers for those additional features, but also example application firmware as well. If you're doing any cloud connectivity and you need cloud connectors, we have examples for that. So I think like Microsoft Azure, AWS, etc. We have add-on packages that can give you that capability as well. One of the packages listed on here is the X-Linux AI package, which adds in machine learning functionality or brings you the support for machine learning capabilities with the MP2. And that's what we'll talk about next. Just briefly, is the neural processing unit and utilizing it to unlock the capabilities of the MP2 for your AI application. Basically, we support the entire process, whether it's training a model um, or taking trained data. So we can support, if you have your own model already, you have data scientists, you've created your own model, you have a trained neural network, it's in TensorFlow format, PyTorch, ONNX, MATLAB, etc. If you have a model like that, you can utilize that on the STM32 MP2, on the MPU. If you don't have your own examples, we do have pre-made models, pre-trained models for various common scenarios such as object detection, pose estimation, etc. They're in what we call the ST Edge AI Model Zoo, and that's hosted on GitHub, and you're free to go and download those. Whatever the source of the model, we have the tools, either a desktop application in ST Edge AI or a developer cloud where you can utilize the tools in the cloud so you don't need to install any tools on your PC. The tools will optimize the model, do the quantization, give you a benchmark, and do a conversion into something that the basic compilation into code that the MP2 can run, whether that's on the NPU, the GPU, or on the core itself. Okay, so basically, in summary, what is X-Linux AI? It's an all-in-one solution. It helps you to develop your AI application for the NP2. It's a framework. It provides the application. It can utilize the common standard frameworks and neural network models. There are a selection of examples in there, but also there's more available in the Model Zoo. It can create a benchmark for the models running on the MPU, and it includes the tools, whether that's Python, GStream, or OpenCV, to develop the applications and get it running on the MP2. Excuse me.